Okay, this is the world's fastest periodic table. We're going to start with the alkali metals. These are group 1, and the groups go from 1 through 18, from left to right on the periodic table. And the group number tells you how many valence electrons the atom has. In the case of the non-metals, which are on this side of the periodic table, the second number in the group number tells you how many valence electrons it has. So these elements, called noble gases, have 8 valence electrons. The halogens have 7. The chalcogens have 6. The nitrogen group has 5. The carbon group has 4, and boron group has 3. I forgot to do the alkaline earth metals. And Cerbera. Then to go across, these are also periods. When you go across, they're called periods. Period 1, 2, 3, 4, 5, 6, 7, 6, 7. This whole section was taken out right after barium and radium. They're called lanthanides and actinides because lanthanum is at the beginning of this, and actinium is at the beginning of this series. And the way you can remember that is by saying sky, Layak. Sky, Layak. Right after Layak, this whole strip was removed so that the periodic table wouldn't be too long. But to go all the way across, we do Helli, Bebkanov, Nina Magal, Sipsco, Arkask, Tib, Kerr, Men, Fi, Ko, Nai, Q, Zin, Gejaz, Berker. Herb Sri, Zern, Mott, Mott, Brewer, Dag, oops, no, I made a mistake. Dag, the Dins and Siptexa, Sistala, Ha, Ta, Re, Os, Og. And then this one says Freyak, Rif, Dib, Sig, Ba, Us, Mat, Dis, Rig, Cn. That's all the elements in the main body of the table. This whole section is called the transition elements. You can call them transition elements. But they're also part of the table called D block. And they're in D block because it's a certain specific filling of the shells that we were going to learn about later. This section of the table is called S block. This whole section is called F block because the F shells are filling. And this whole section is called P block. Now the lanthanides, the part that comes right after lanthanum, and the reason I want you to remember Sky Layak is because when you write the atomic numbers of the elements, they all go from left to right. So it goes 1, 2 for helium, and it tells you how many protons are in each one of the elements, and it follows a very easy pattern to predict. It's like writing numbers in order, and the pattern never breaks except when you get to Sky Layak. 12 is magnesium, 13 is aluminum, 14 for silicon, 15 for phosphorus, 16 for sulfur, 17 for chlorine, 18 for argon, 19 protons for potassium, 20 for calcium, 21 for scandium, 22 for titanium, 23 for vanadium, 24 for chromium, 25 for manganese, 26 for iron, 27 for cobalt, 28 for nickel, 29 for copper, 30 for zinc, 31 for gallium, 32 for germanium, 33 for arsenic, 34 for selenium, 35 for bromine, 36 for krypton, 37 for rubidium, 38 for strontium, 39 for yttrium, 40 for zirconium, 41 for niobium, which used to be called columbium by some tradesmen, but then that didn't stick, so they used the niobium stuck instead. 42 for molybdenum, 43 for technetium, 44 for ruthenium, 45 for rhodium. I could be wrong about that. I'll come back to that for that one. 46 for palladium, 47 for silver, 48 for cadmium, 49 for indium, 50 for tin, 51 for antimony, 52.
Hello, Mr. Bozzi.
Yes, hello?
Can I please see Stephen or Lana in guidance?
Yes.
He just has to drop something off for me.
Okay.
Thank you.
Mess up the video, man.
We won't count that as new. 53 for iodine, 54 for xenon, 55 for cesium, 56 for barium, 57 for lanthanum, and this is where you have to take note. The lanthanum breaks and the pattern continues 58, 59, 60, 61, 62, 63, 64, 65, 66. And these numbers, by the way, mean how many protons there are in the atom. And it continues. Once you get to 71 over here, it continues with 72 for hafnium, 73 for tantalum, 74 for tungsten. You might wonder, why is tungsten have the symbol W? Because it stands for wolfram, which was the mineral it was first found in. 75 for rhenium, 76 for osmium, 77 for iridium, 78 for platinum, 79 for gold, 80 for mercury, 81 for thallium, 82 for lead, 83 for bismuth, 84 for polonium, 85 for astatine, 86 for radon, 87 for francium. Francium was never actually discovered on the Earth. They just knew it had to exist because there was a hole missing in the periodic table that had to have 87 protons. So francium was discovered before it was discovered, if you could understand what I'm saying. 88 for radium, 89 for actinium, then it goes to 90 down here. 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103 protons for that element. Then we continue with 104 for rutherfordium, 105 for dubnium, 106 for seaborgium, named after the famous physicist who discovered 10 different elements, Glenn Seaborg. 107 for borium, 108 for hassium, 109 for meitnerium, named after Lise Meitner, a famous researcher. 110 for, I believe it's stadium, 110 for ruthenium, and 112 for copernicium. Now we also have to put the symbols for the lanthanides. The lanthanides are Chep, Pern, Pim, Sim, Pimsim, U, Good, Tib, D, Ho, Tim, Ib, Lu. And the last one, the actinides, is the, pon, pu, am, come, back, ka, fes, f, m, no, lur. That is the entire periodic table by memory.